Thank you for joining this call, where in next 25 or 30 minutes, I'm going to run us through the introduction level of a load testing. As I mentioned previously, my name is Lukasz Nowak. I live in Poland. Usually I am called a senior front-end developer. However, I am quite dedicated to automatic test of front-end applications. Usually I am an author of quite vast, complex, and sometimes even complicated testing suites, including things that we are calling the functionality, integration, accessibility, visual regression, and several other testing suites too. I didn't mention a subject of this presentation because load testing is considered a peripheral type of testing, something which is less important than integration or functional tests that has to be run on each run of the automated pipeline on CI/CD, right? To understand why is that so, maybe let's rewind back to the past, like 25 years ago, to the world as it was at the end of the 20th century. And I know that I am quoting Morpheus from Matrix, the movie right now, but this is the good markup of days I am referring to, right? So imagine yourself that Google is not a leading search engine on the internet. And it didn't happen just because we have some magical AI-based solution. It happened just because Google is still considered an emerging company offering some geeky tool not everyone is willing to use or understand at the first place. Imagine yourself that there was no live internet streaming back in the days, just because if you were willing to download a simple MP3 song, it took you at least 1 hour to get the entire file, and this is if you were lucky. And I know I am referring to downloading MP3 songs, which sounds ridiculous right now. However, back in the days, this is what we used internet to as well. So as you can see, the time perception was completely different back in the days. And the most reason for that was that basically there was a load bandwidth of the internet, but also ourselves, engineers, we didn't help with that very much. This is just because back in the days, most of the internet services was quite monolithic when it comes to the infrastructure. There was no dedicated layers of front and back end DevOps. Everything was under the single source code. So for example, if you have posted a form, then you initiated the connection to the what we used to call a server in order to add the data to the database. Then the server responded with a location header, which redirected the client to the new URL. And after that, there was another communication with the server just to get the data from database. And then it has been injected into the template, which created a final HTML markup of entire page. And just because there was no frameworks, dedicated front-end frameworks like React or Vue or any other thing to automate or speed things up, we've been creating this HTML markup over and over again, every time. And basically, those markups might got big, which obviously wasn't performant to get it through the slow internet connection. So as you can see, there was tons of opportunities to make things better. But in order to know how to do that, we require to get some tools and also some metrics in order to understand whether our effort works at the first place. This is where we started to experiment with things that you may call right now a load testing. In one sentence, load testing measures the service performance. It is an amount of time necessary to finish some operation, like, for example, fetching your holiday picture from content delivery network, or just response time of an endpoint. This is most common case of load testing. This metric is quite good just because it encapsulates all potential pain points in the unified metrics. I mean, we don't want to understand what is the reason of potential underperformance. We just want to know how the performance looks like at the first place. So there is also an interesting side effect of such testing too. Triggering internet resources create logs on service. This is like ABC of creation of service. This way we can get an information of how the system works. And the real magic appears if we correctly scale the tension and the length of such tests. This is why load testing is not only one type of tests. It is rather a group, and each type of tests gives an answer to a completely different question. During the talk, I am going to focus on 4 most important and, in my opinion, most popular types of load testing. And we will start from the one which is sarcastically called a load testing. In order to start with that, we have to create one definition, the definition of performance. We have to understand what does it mean. So let's say that the tested endpoint is considered performant if it's able to answer with 100 milliseconds or even faster. Once we have this definition, we want to understand how many users the tested endpoint can serve in parallel and being considered performant. Obviously, it really depends on the business we work. However, let's initially assume that it should serve 100 users in parallel. The simplest load testing scenario is for simulating such a traffic and gathering statistics. And it can be described visually with the graph I am displaying right now. So as you can see on the horizontal line, we have the execution time of the scenario, and on the vertical line, we have amount of virtual users hitting the same endpoint in the same time. So probably you can imagine how this test is going to work like we are starting with no traffic at all, then we are hitting up the tension up to 60 virtual users, and then we stabilize the traffic for several minutes. After that, we want to get to 100 users, stabilize for 1 minute or 2, and then rank down the traffic to the 60 users back. And after that, we want to cool down the traffic to 0 users at all. After that, we can sneak into the statistics, and if it finds out that basically the endpoint is responding below 100 milliseconds, it means that basically, it is performant. We can serve 100 users in parallel, right? But obviously, if it looks like the endpoint is not performing very well, we also can start estimating the lower amount of virtual users hitting the same endpoints in parallel. So nevertheless, we want to. I mean, it doesn't matter what is the score after the first iteration. We want to perform several more iterations just to identify how many users the endpoint can serve and be performant. This is what we call a throughput of an endpoint, and it is a starting point for us to perform other types of load testing. So when it comes to stress testing, the idea of this is to simulate increased traffic, like if there was a Black Friday or any other increased use of the service we are responsible for. So let's say that our calculated throughput of the endpoint is 100 users. So the test scenario is as it is. Like we want to start up some traffic. We want to initially stabilize the traffic in 100 virtual users, and we want to perform such a traffic for several minutes, just very stable, very slowly. After that, we want to slowly double the traffic and then stabilize this traffic on 200 virtual users just for a few minutes. And then we want to perform several other increases like this way, after which we will cool down the traffic very, very slowly. As you can see, I'm using the slowly word several times, and basically the predictability is a key point for this test. I mean, we want to increase the traffic very slowly in order to make our infrastructure react on the increased traffic. Why is that so? This is just because we want to make sure that the infrastructure is able to handle such a traffic. I mean, new pods may be created and deployed, and basically, we will be still online. This is just because when it comes to the Black Friday or initiative like this, basically it is common knowledge that internet is getting a little bit slower during Black Friday, right? So our clients may understand that our service will be a little bit slower, but what they expect is that it is going to be still online. This is just because we want to earn some money during Black Friday, right? So this is our main priority, to make sure to understand whether the service is going to be online during increased traffic. And also we want to identify whether the system is able to scale down automatically when the increased traffic will get lower, to be honest. So yeah, the main purpose of this type of tests is stability and predictability. And this is something completely different from the next testing scenario, which is spike testing. Spike testing is starting with the estimated throughput of the endpoint, even a little bit lower, like let's say the 80 users. And after that, we want to hit the endpoint very strongly. Like we want to create the completely crazy traffic, like 15, 18, 20, 100 users, 20 times more that the endpoint can serve. We don't want to hit with this traffic slowly. We want to hit it hard and very fast, very strong, and then disappear after a short period of time. This is just because we don't want to give the infrastructure any opportunity to react on such increased traffic. We just want to destroy the infrastructure. This is the simulation of a DDoS attack. We just don't want to measure the performance of our endpoint. We just want to destroy the infrastructure and then perform the post-mortem investigation. We want to understand whether our infrastructure is able to delegate the increased traffic to some empty space, and whether it is able to automatically remediate from the disaster when the DDoS stopped. If it can, it means that's okay, our infrastructure is automated. If it's not, it means that we have to perform some fixes, or maybe we have to have DevOps on a call on a permanent status, which is very bad from a perspective of maintaining the product. And it leads us to the next type of testing, which is a SOC testing, and it is the most boring kind of testing ever. This is just because nothing interesting happened for a lot of time. Like if the estimated calculated throughput is 100 users, then we want to hitting the endpoint with 100 users for a couple of hours. And the most boring thing is that basically the interesting information is starting to appear at the very end of such test after several hours. So if you ask me why do we want to perform such test, I will answer you that basically we want to understand how our service endpoint product will look like after several years of consecutive using. I mean, this is something we want to predictable. What will the project looks like during the life cycle of the product? Like, for example, let's say that we are creating this product. Then, obviously, we are having some dedicated team taking care of such a product, providing some fixes, some new features and stuff. So basically, we know what is this product all about. However, after several years, most of the team is focusing on some other products, leaving the company. And after several years, basically this product is going to be machine doing ping, which was described by Monty Python very well. So with such tests, we want to understand how is the infrastructure created. Like maybe we will have some memory leaks, or maybe we have some weak cache cleaning policies, or maybe we are logging too much and basically at some point we may run out of quota. If not such a thing appear, it means that basically the product is automated, which is good just because it will maintain itself. If not, on the other hand, then it means that sooner or later someone will have to, move away the dust from the project and try to maintain that for a while, which might be very costly. And yeah, right now we know some theory of load testing, so we can head to tooling to perform such tests. And from what I understand is that there are several tools for load testing on the market, and I would propose the one which is called K6. This is not just because I am connected with Grafana Labs or authors of K6 anyway. This is just because I found this tool somewhere on the internet space and started to experiment with it. And what I liked mostly was that basically I can create a test scenario with JavaScript, which is very helpful for me as a front-end developer. So when it comes to installation process of the tool, there are several ways of that. You may use the command line, fetch the Docker image, or maybe you may download the installer dedicated to your operation system. And after several clicks, you have the engine on your local machine. When it comes to the writing test scenario, it is as simple as it is, like 14, 15 lines of code, something like that, nothing else. This is the entire test. Most important part of this test is the stages, which is the representation of graphs displayed few slides before. The test body is defined by a default function. There we point out an URL of tested endpoint, and optionally we can create some crafted statistics by using a check function. When it comes to running such tests, it's one-liner, just a run command and an argument of a file which contains the scenario of such tests. And after several seconds or minutes, we can see the statistics, which will look something like this on the command line. And probably you may not understand what is it all about, so let's magnify to the most important part of those statistics. From my perspective or experience, it looks like the most important statistics is the HTTP request duration times. This is just because we really don't want to care how close is the server to from ourselves. Like in reality, how long do we have? How much time do we have to spend to connect to the server? We don't want to understand what is the time of executing our API call by the server itself. We just want to encapsulate everything in one metric, and this is the request duration. And I believe that the average metric is the most important one, just because, as you can see, during this test, we hit the endpoint 1,300 times, which is a lot. So we really don't want to focus on the minimum and maximum. We most probably want to focus on the average time of HTTP request duration. The statistic like this is quite vast. I mean, it is very interesting, but also you can create your own statistics by using check function. For example, several slides ago, I used this function to understand how many requests responded with error or with 200 response, which was very helpful for us too. Obviously, you may export the statistics into the JSON or CSV file and attach it to the job of a CI/CD pipeline as an artifact. But also, you can stream the statistics to some external service. The Grafana paid service is the tool of choice, the initial tool of choice. However, K6 is able to integrate with other tools like Datadog, Elasticsearch, probably you name it, and most probably you have it, just because K6 is very flexy, I would say. When it comes to the performance of K6 itself, besides the fact that tests are written in JavaScript, the core engine is written in Go. This is what I understand why this tool is very performant. I mean, I know that it is able to handle 30 up to 40 virtual users hitting the same endpoint in parallel. When it comes to firing tests on a local machine, it looks like, I mean, I read some statistics that basically K6 is able to handle few thousand of virtual users. CPU seems not to be a problem for that. Our RAM might be a little bit problematic just because each user requires 1 up to 5 mega of RAM. However, from my experience, when you want to run load tests on your local machine, it is not for real load testing. It is rather for some kind of an investigation or experimentation. So probably 100 users will be maximum you want to use. So basically, yeah, you will be able to run those tests on your local machines. And yeah, I've been using K6 for last couple of years. I wouldn't say that it was, I've been using that very often. It was rather an accidental use for some investigation. However, I have some nice impressions after using that. First of all, I love K6 for lowering the entry level to the load testing world. And it's been lowered extremely. like you remember this 14 or 15 lines of code, that was real test, real functional tests, nothing else. And it was the simplest case, just for experimentation, for investigation. If you want to do that, that's okay. K6 is able to do that very fast and very, very easy and for free. This is very important. If, on the other hand, you want to invest on some more complicated testing suites, like, for example, several thousand of users, which have to be authenticated, then you have to use this authorization token, put it into the cookie or header. Then you have some, queue of different API endpoints to hit. Then you also can create such a complicated and sophisticated testing scenario. And also you can use dedicated infrastructure to perform such tests. K6 is configurable and it allows to be used for free and also with connection with some enterprise paid services, which is very good. I recommend use load testing, especially for major enterprise companies. This is just because if you want to create a real load testing scenario and you want to perform such tests quite regularly, it means that you have to have a dedicated full environment for that, like non-functional environment. In most cases, probably you want to destroy this environment by using spike tests or something like that. So you have to have some people knowing how to remediate from such a disaster. So as you can see, everything is a matter of cost, right? Like you have to hire right people, and you have to create a dedicated environment to be able to handle such tests, which means that it is a cost, which means that this is a tool for rather rich companies. But I also recommend at least the simplest scenarios, load testing scenarios, for organizations facing traffic tensions, like businesses profiting from Black Friday or some periodical sales which may increase the traffic. Also, we have to remember that we are on the war right now, both the real one and the virtual one. So if you are an owner or business or of business or government related critical service, you have to expect some sort of DDoS attack sooner or later. So if you really want to perform those spike tests and know whether your infrastructure is able to remediate after the disaster. So that's why I recommend that. But I also recommend performing at least the simplest scenarios to all developers, even front-end developers like myself, especially if you are following the latest architectural pattern when it comes to creating front-end application. I am referring to the backend for frontend architectural pattern, which is a thin backend layer that's supposed to be included to all frontend applications. Most probably, for most of you, it is kind of a transparent layer, just because it is served by probably all full-stack JS framework that are out there. However, you still are creating things like this, and you may be interested to understand how performant your endpoints was. Some time ago, we've been experimenting with such approach, and this was the shape of the ecosystem as we thought it was. And we found that basically our application was not very well performing at some point. So we performed some manual tests, like trying to play with our application. And then we found out that probably the company's service is the one that causes troubles. I mean, it's been responding, its endpoints were responding very slowly. So we started to dig a little bit deeper, and we find out that basically the overall shape of the system we've been communicating with was not as we initially thought. This was just because company's service was communicating with a lot of other sub-services in order to get data back to our BFF layer. What we found out was that the endpoint we've been using were returning a lot of data, and sarcastically, we required only small portion of this data. So we started to do some investigation. I mean, we ran through the Swagger of company service, and then we found out that there are several endpoints that do not hit tons of other microservices. So we found out that the one main big API endpoint is not performing. However, we may call three smaller API endpoints better performing in order to get the data we need. And we thought that this fix may help us with the performance of our application. So the plan looks good. However, we required some statistic in order to understand whether we are going into the right direction. And then K6 came very handy with that. I mean, we have created the simple load testing of 100 virtual users hitting our BFF endpoint for something like 2, 3, or 4 minutes, something like that. And then we created then we received the results of such tests and we stored that into the Confluence. After that, obviously, we have developed the fix, and then we run the same test against the same API BFF endpoint, however, the fixed one. And what we found out was that we increased the overall performance for about a second, which was considered a nice groundbreaking change to our performance.